What is going on YouTube? It's Jake and welcome back to another video where we're talking about computer science. Today, we're going to hop into some code. I know, so exciting. We are going to be hopping into some C code and we're going to be looking at some Windows process communication, inter-process communication. Now, Jake, why are we looking at this? It's just something I'm interested in. I've been working with the Windows API recently and I grew up only programming on Linux systems for the most part, programming on Mac OS. And when it came to processes, we're using forks, and it was pretty easy to pass information around via pipes, and with files. And the same thing is kind of true on Windows, except with this term called handle. Windows uses handles for, inter-process communication, for just making processes. I was reading an article, a handle is pretty much like we have a process and it has a bag of tools, and each handle is the tool that the process can talk to and use to pretty much become an application. So enough talking about handles. Let's actually look in the code. It's not going to be too crazy. So here we are, guys. We're looking at our Visual Studio Code, our favorite editor of choice, and we are going to change this color to green. We're going to make a main process and a child process. Essentially, what we can imagine here is that we have a parent that's calling a child, and really that it sort of works, it sort of doesn't, what we'll find out, but essentially I'm going to make a variable in my main C, and I want my child process to be able to access and modify that. And it's not easy on the Windows API, I can tell you. You see this right here? This guy, oh my gosh, there's no hiding it. There's no abstracting it. We're no longer in Python. We're not in Golang. We're not in any C#. Okay, we are in C, and we are talking with our operating system with Windows.h. So there's not really much abstraction after this. This is the bare bones. This is when you know you've crossed the line, when you start talking to Windows.h. So yeah, we're gonna look at this code in a sec, but just to kind of maybe talk about it a little bit more abstractly, and we're talking about mapping memory from one process to another. We have two separate processes, and these processes, you can kind of think of them as containers. They're containers. They are contexts, and that's all they are. The things that are actually running your programs are threads. So processes don't run, threads run. That is probably the one takeaway you should take from this video if you haven't heard that before. So we have our threads that are going to be running in main and in our child, and they contain a context, they contain a stack and a heap, and that's how memory is saved and memory is accessed. However, when we have two different processes, we have our context here and this context here, and they cannot communicate with each other. They just cannot do that. And in Windows, there's two main ways to make those processes talk to each other. It's going to be oh my gosh, named pipes. I'm not going to spell that out, or maybe I will. Oh my gosh, not too bad at typing. Named pipes and memory map files. Memory map files. There's an old saying that everything in Linux is a file. Well, everything in Windows is a frickin' handle. Everything in Windows is a handle. So that is what we're going to be looking at. Essentially here, what we're doing is we're going to be making a file mapping. We're going to be making this file mapping. And that's going to pretty much make an object on our actual physical memory. It's going to make it in our DRAM. And we're going to then make a file view within each... Oh my gosh, that was awful. We're going to make a file view within each one of... Oh my gosh, my hand, my face was blocking it. It's still blocking it. Okay, well, all right, there we go. We'll zoom it out real quick. But what were we doing? Essentially, we're going to make a file mapping, and we're going to view this map. This is going to be a pointer, so the file view is going to be a pointer to this object. The file views are pointers to the object. And that's how we're going to share memory between these two processes. Now that is it's pretty cool. I find it pretty cool. I think Linux does it a little bit easier, but we're working with the bare minimums. Windows API, this is how every process on your computer works if they are two different processes sharing memory. They're doing that, or they're doing named pipes. So let's look at this code again. Okay, like I said, we have our main. We're inside of our main right now, and we are making the file mapping. We're doing that good stuff. Okay, Jake. One day I'll get good at using zoom in, and when that day comes, it'll be really fun. So we're creating the file mapping. You know, if it was an actual file, you could give it a name here, which is kind of cool. So like it literally works as if you're loading a file into memory, but instead we're not making a file. We're saying, hey, we're just going to put some bytes in memory. And there's some attributes, you know, if you wanted your child processes to like automatically handle or inherit this stuff. I'm not too sure exactly what this attributes guy is doing. And what happens if you change it from null, but every tutorial I saw had it as null, so I was like, okay, we're keeping it null, guys. We're keeping it null. We then have FL protect. This is just like what I can do with this memory region. You know, if I wanted to read it, if I wanted to write it, cool. If I wanted to give it an offset, maximum size high, maximum size low. So maximum size high, I guess we're just going the opposite direction. You know, Windows is weird, okay? So instead of going from like, we're just going from 0 to infinity. And I'm going to allocate the size of integer, simple integer, which is going to be 4. So we can imagine kind of like maybe like a, you know, like a 1, 2, 3, 4. So we're just allocating this much memory kind of thing. Bam. And we're putting that on our physical RAM. It's getting put on RAM. And then we are going to make that view. We're going to make that view so I can bring it in to my process. So I like to think of it as this is like me putting it on memory, and then this map view of file is me bringing it to my process. So you will notice here that we made a handle, which is kind of like, I think it's a D word. It's a pointer. So I'm bringing in that pointer into this map view of the file. So it's a handle file mapping object. Bam. This is going to be the object we're using. The access, we want full access. We're going to be writing to this guy. The file offset again, and file offset low. So, you know, I don't need an offset here. You can think of it kind of like as an array again. So if like I had multiple cells here, and if I wanted to like grab, you know, from here to here, you could do that. You could absolutely do that, which is kind of cool. A lot of, I mean, it's literally just working with continuous blocks of memory. That's what it is. It's like an array. And we can read however many bytes that we need and cast those bytes to whatever type of object we need to cast it to. So we come down here. We have a little check, you know, if it failed. Holy smacks, let's stop the program. Something bad happened. Don't want that, but don't worry, guys. I already coded it for you, so you don't have to see me struggle. And here we're just going to start. We're going to 0 mem that. Okay. Actually, I'm getting ahead of myself. We create our file mapping. We create our view of the file to bring it into memory. And now, after doing this, we now have a pointer to a block of memory. And we're going to set it equal to 42. Bam. It's a block of memory. We're casting it to an integer. So we're going to dereference it and set it to an actual value. Bam. The memory has been set. So now we're going to start up a process. Okay, this is part 2. So we got our memory. We're going to start up a new process and try to read it. And creating a process is a couple things. One, we're going to actually zero out some memory. Yeah, we're talking to the Windows API guys. So we're down low. we're gonna make an object the size of startup info, so a freaking process, and we're going to zero it. We're gonna make it sure all the value in there is null. We don't want to overwrite anything. So making a new block of memory, and we're gonna create a process to go in there. And everything is kind of simple. You know, we have the name of our executable. If it's an application to run, I want to say that this executable name is if it's like in your path on your operating system. Maybe it'll work if you set this guy. But here we're going to use a command line string because the process is right here in our directory. So you can kind of think of it as, oh hey, just /child.exe. If you wanted to add some command line arguments to it, you could also make this like, you know, parameter like 1 and 2. You could pretty much have command line arguments be sent to that process as well, which is pretty cool. Security attributes, you know, if you needed to be in a certain group to view the file. Thread security attributes, I really don't know. I really don't know what your threads are doing that are so scary. But what are you guys doing with your threads, okay? What are y'all doing? Creation flags, you know, whatever these guys are doing, they're doing stuff, okay? Current directory, you know, not specifying it, you know, this is all the information that you need to make a process on Windows. And you know what you can do? You know what you can do when you're on Linux? You can just do like freaking fork, bro. You can do fork, dude. Just fork. Actually, you don't even need brackets. You just do like, you know, semicolon. Bam. That's how you do it on Linux. And look what us Windows developers are doing. We're doing so much. Okay. So we call this process. Bam. We're actually gonna wait for the child process to end before closing out main. And then yeah, we're gonna close our handle. We're gonna unmap from the file. You know, save that memory. Don't want any memory leaks. And return 0. Exit the program. So that's main. Wow, y'all have been so patient if you're still watching this. Holy smokes. And then we're going to have a child process. And what this child's going to do, okay, is it's going to... I feel so bad that I'm not running it first. I'm just talking about it first. It's going to be fun. Don't worry, guys. Don't worry. It's going to be fun. We have our child process. We're going to open. So we already created the place in memory, so we don't need to create it again. We can just open the file thing. Oh my god, my computer was beeping at me. I was scared. And we're going to call it mem test. I guess that's what I forgot to say over here. So we did create this region. We made a handle and we called it test mem. So when we're opening it up over here, we're going to open up test mem. That's how we will get it, which is very cool. Very cool. And so we're just going to open it up, and we're going to try to read that value. We're going to try to read that shared value, that 42, that we got from the homie. And then after that, I think we just sleep for a very long time, because we're going to open it up in Process Explorer and kind of look at some of the things that are happening in the back end. So that is essentially what we're going to do. We're going to read the value, read it from value, and hang out and chill. So let's do it. I think scroll up the terminal here. I think we're going to open up Sigwin. For anyone that doesn't like Windows but wants to have a Linux feel, okay? First off, you're missing out because Windows is pretty cool. But you can download Sigwin, and you can download a bunch of Linux tools like LS, like PWD. You can do all the stuff. I mean, I can even tar in here, I want to say, can I? I'm gonna like totally blow up in my face. Yes, you can tar. You can tar, which is pretty cool. So, and that's for Windows. So we can actually type out clear. But let's run. We could compile this guy using main.c, main. Then we could gcc child.c. Output is child. And let's just run main. See what happens. So, bam. Parent process, fork child with PID of this. we're in the child process, and we can read that 42 value. In child process, value from shared memory is that. So that's cool. That's very cool. But let's actually like look. Let's actually take a look at what's going on with this process. That's why we're having that wait step. You'll notice, so first off, Process Explorer. This is what this guy is. You know, if I came over to Windows, it's Proc Explorer. You can download this from sysinternals. It's a tool. You download it. It's a command line tool, and you can open it up, and it'll launch a GUI. So I guess it's actually a GUI application. But as you can see here, we can see all the processes that led us to here. First off, you know, I'm in Visual Studio Code. First off, that's the parent process. And even before that is Explore.exe. Okay. Explore.exe, code, my PowerShell terminal. Very cool. My SH, my Sigwin. And then we have here main.exe. And we can view a lot of things about this file. First off, what's kind of cool, if you wanted to look at the CPU count, somewhere over the rainbow, there is a CPU count. I think, yeah, sorry, cycles. You want to see those CPU cycles? Okay, you want to know how much your code is running. We're not talking about milliseconds. We're not talking about abstract concepts called time. We're talking about how many times did this freaking program run on my CPU, which is pretty cool. You can also see, you know, virtual memory, physical memory. That is quite cool, guys. It's quite cool. So a couple things. I think it's done sleeping, so let's run it back. Run it back. A couple things. You'll notice that when we go to threads, like I said, processes don't run, threads run. There's going to be 2 threads, and you're like, Jake, what the heck? You only had 1 thread, and you started another process. Well, guys, Geeks for Geeks, Stack Overflow, they lied to you if you looked at the surface. Every process, 2 threads, one's a user space thread, one's a kernel thread. I lied to you. I was making up answers in my mind. There's 1 thread. There is 2 stacks though. There is a user stack and there is a kernel stack. Needless to say though, you can see the DLLs. You can see what DLLs are necessary to make your code work, which is fun. Okay, you thought you were making Hello World. You thought it was all you. Then you come in here and you're like, holy smokes, dude, what in the gods, what in the computer gods before us did they do to make this thing work? It's quite crazy cool. But then, all right, we had our DLLs, we had our threads, now we're looking at our handles. As you can see, you know, we have pointers to directories, files, mutants, sections, and threads. So I actually have a pointer to my thread, which is kind of cool that I have a handle for that. We'll have to explore that in another video. But essentially, I'm starting this guy up. That section is right here. We started up a process. We made a region of memory in our VRAM, in our physical RAM. And then we made a pointer to it in the form of a handle. And we passed that between our main process and our child process. And so if I go to my child process here, you know, we're clicking on the next one down. A lot of the handles are going to be the same, but eventually we come down here and we see that we have a section called test mem as well. So, ladies and gentlemen, would you look at that? That is pretty much what I wanted to talk about in this video. I mean, honestly, just doing some cool things. We're getting low level. We're looking at that Windows API. No more abstraction. It's just us and the operating system making some memory communicate across processes. I think it's cool. I hope you found it was cool. Thanks for watching. We'll probably make a video on creating named types soon, and just covering more cybersecurity news. So, like and subscribe, guys. Peace.